Everybody ready? Jennifer and I met 9 years ago at the NLA familial hypercholesterolemia meeting before that NLA guideline, and we realized that we both enjoyed each other's cynicism and sarcasm extremely well and actually had similar ideas about atherosclerosis. So we started collaborating on this hypothesis that we're going to present to you today. We really appreciate the opportunity to present these ideas because we've been working on them and reiterating them now for, I think we published the first paper in 2013, and there's been some new ones since. So we're going to do share the podium for different parts of the hypothesis development, and then we'll end talking about clinical trial design to test the hypothesis. So building evidence for the next treatment paradigm, curing atherosclerosis. So Jennifer has a boatload of disclosures, and of course I just have my wife as my only disclosure. So why cure atherosclerosis? Can it be done? And we want to convince you that now is the time. And cardiovascular disease, as we know, remains the leading cause of death and major cause of morbidity in the US and globally. In 2015, 42% of the US population had cardiovascular disease, so it's highly prevalent. And if you could just eliminate CVD, it would increase life expectancy by about 7 years. It's the #1 cause of healthcare expenditures, and these costs are expected to double as the population ages. However, if you cure atherosclerosis, it eliminates CVD within a generation and could save $1 trillion a year.
Just think of what you could spend that on.
That's correct.
So you've seen these slides already. You know, this is right, Oman, Arabia, North Africa, amongst the highest rates of cardiovascular prevalence in the world already. So the impact of this idea would be huge, and I think it's particularly important because we know that people are predisposed genetically to getting cardiovascular disease, as I alluded to before. And there's been some really interesting data that's come out. This is in 3 different cohorts, all European ancestry. But what they've done is kind of divided them up into tertiles of genetic risk load for cardiovascular disease. And you can show that those with the healthiest lifestyles still only cut the risk in half. So as much as we love to talk about promoting lifestyle, I think really the answer to this problem is going to be drug therapy. And what we're seeing in the United States, and actually what you have here, because you have premature accelerated atherosclerosis, we actually see half of the cardiovascular events occur before age 65. So it's not a disease of old people, it's a disease of young people.
And I think in the US, the cardiovascular event rates have actually plateaued and are increasing in women between the ages of 40 and 60.
So you've seen this many times, and I think if you, again, always kind of go back and think about what's happening in the artery. Cardiologists do this, but then they just go in and do a procedure and open it up and think they're done, but you're not done, because you really have to think about what the atherosclerotic disease process is, starting in childhood and progressing. And like we mentioned before, you know, if you're, most of what we're talking about is giving, you know, statins once people have cardiovascular disease or diabetes and all those things. It's too late. They have a huge burden of atherosclerosis. You're never going to get it to go away. It's fibrotic, it's calcified, and you're really going to see the biggest benefit starting earlier in life.
Yeah, and then I think when you think about evidence paradigms and people wanting to prevent events, I realized very early on in my career that the only thing I could really prevent was atherosclerosis. What happened downstream was was a whole different arena, and I also thought that a lot of the risk factors for a heart attack or the acute event were different than the risk factors for atherosclerosis development. A classic example being cigarette smoke exposure. So if you're not a smoker and you go into a bar where there's smoking, that immediately turns your blood vessels into the blood vessels of a smoker. And so if you have FH and you don't smoke and you've been healthy, you walk into this bar, smoke hits you, boom, you have your heart attack.
So I think really what we should be thinking about this disease of atherosclerosis is the disease we're trying to prevent. It's really how we treat hypertension, right? We don't wait till somebody gets renal failure to start lowering their blood pressure, right? So why would we want to wait till they had a cardiovascular event to start prevention? So I think hopefully you've gotten the idea that ApoB lipoproteins, so LDL, non-HDL cholesterol, each one has an ApoB on it, so they're the atherogenic lipoproteins, are really a fundamental causal factor in atherosclerosis development and progression. And let me just show you some of the really compelling data we have to show that lowering ApoB lipoproteins, i.e. LDL and non-HDL cholesterol, has a really profound effect when started earlier in life. And these are data from the cholesterol treatment trialists, so statin trials. But what they did is they broke down the risk. These are all primary prevention patients, and they just calculated a risk estimation, based on risk factors like I showed you before. And you can see that the lowest risk people, less than 5% or less than 5 to less than 10% that are highlighted, they have twice the relative risk reduction as those at higher risk. Now, age is the primary driver of this risk score. So these are younger people, and they're having twice the response to cholesterol lowering, probably because they have more plaque that's amenable to regression and treatment. We also have the data from the PCSK9 genetic data that's gotten us very excited and actually started this whole PCSK9 inhibitor story. We know that people who have PCSK9 loss of function mutation, heterozygotes, so they just have one loss of function mutation, their average LDL levels about 100 through their lifespan, they have 80% lower cardiovascular disease. So more evidence that cholesterol earlier in life when it's low largely prevents cardiovascular disease later. And I just wanted to point out in this one study where this data comes from, these were people with lots of other risk factors. They were all African Americans, but they were obese, they smoked, they had hypertension, and they had diabetes. But having that low LDL through their life protected them. So I think that's really a critical point.
But it doesn't protect them from heart failure.
Hey, come on. We're not having a debate here.
We're not allowed to debate, okay. I'll be nice.
All right, so you can talk. You talked already about some of the genetic data, and that the lower the better in terms of lifetime risk of atherosclerosis. So you can really start to conceptualize, I think, the event horizon for cardiovascular events and death at different ages. On the left is the arrow that's, the FH patient, right? So they've got LDL levels of 390 or something.
Right,
They're
sure.
having, cardiovascular events in their 20s. Kind of the average person, or at least the average American with cardiovascular risk factors and an average LDL of 130, they're starting to have heart attacks and strokes in their 50s and 60s. And then these PCSK9 loss of function mutation people with the low LDL, some are still having events, but if you're 95 when you have your first event, that's not doing too badly. So having a low LDL through life is really important. Now, at the end, I'm going to talk a little bit about genetic engineering, but before we get there, we have an idea that perhaps we could recapitulate that PCSK9 loss of function mutation with intermittent LDL lowering therapy to regress atherosclerosis. And then we'd really only have to treat people every decade or so, or maybe even longer, to try to recapitulate that bottom curve.
Yeah, so I think that's the key part of the concept. I think I said earlier in the meeting that if you could wear your blood vessel on your sleeve, people wouldn't have any trouble deciding when to treat atherosclerosis. And I think our idea here is that as you're early in the course of atherosclerosis, you could treat for 2 or 3 years, regress the atherosclerosis, and then stop treatment until it came back later in life.
Right, because it's a disease of decades.
Right,
And
correct.
so it gives you a window there. And just to really hit on why we're focused on lowering LDL cholesterol and this whole idea, you have to have LDL cholesterol elevations to get atherosclerosis. And if you don't have them, you don't get it. And so you can have homozygous FH, right? It's sufficient without, I mean, if you're 8 years old, it's not inflammation or hypertension or diabetes, it's cholesterol. But on the other hand, there really seems to be an inflection point. This graph here really is non-HDL cholesterol, which is 30 milligrams per deciliter, or what, 0.8 millimoles higher than LDL. But you can see there's an inflection point, an LDL of about 100, non-HDL about 130, and below that point, people are just not getting atherosclerosis. So we have such a large amount of data. Now the other converse thing, because this is a lipid meeting, so you don't have the inflammation crowd that has been talking to you. But
sure.
I just want to...
They carefully selected the speakers.
That's right.
They carefully selected the speakers so the inflammation crowd isn't here.
That's right. So, but it disabuse you. I mean, you have to have LDL to get atherosclerosis. And this, I think this is an elegant natural experiment. There's a tribe in the Amazon called the Samane. And they're hunter-gatherers. They eat fish and rice. They have really low-fat diet. Their LDL levels are very low through their lifespan. They have terrible parasite loads. They have high CRP levels. They don't have any atherosclerosis because their LDL levels are so high. So it's really LDL that's driving this whole issue.
Well, there also are Mendelian randomization studies which show that CRP is not a factor.
That's right. So it's really, that's why we're so focused on getting LDL down. And this is from a nice review paper we did. And you've seen these graphs or these figures so far about, how LDL goes into the subendothelium and is retained. It sticks. It starts to stick if you have other risk factors or genetic predisposition, and then they aggregate and they turn into foam cells, and you start to get the lipid-rich core, and then it continues to grow and get eccentric modeling, and there's all these mediators and cells and all this stuff going on. It's really a mess in there as a result of this toxic retention, right, of the ApoB lipoproteins.
Yeah, so another way to think about it is that atherosclerosis is really a vascular injury, and so when your body gets injured, it heals, and that healing is where the inflammation comes in. So what you have is this ongoing process of injury and healing, and the risk factors take hold and create atherosclerosis when the body's ability to heal the vascular injury is overwhelmed. And that starts to occur. There's aging-related factors plus risk factor burden issues, and that gets the process going.
But what we know from the animal studies is if you take away the toxic insult of the ApoB lipoproteins, you very low blood levels, so there's nothing going into the cells to continue injury. It actually lets the natural process heal the artery and resolve the existing inflammation. And if you do this in early enough cholesterol plaques, you can completely regress the early plaques through this natural healing mechanism. And what's interesting, there's probably genetic factors in terms of, I mentioned in my talk resilience. So there are probably people with really good resolving factors, and there are other people with really bad ones, and so they have accelerated atherosclerosis.
Right, yes. So I think there's definitely signals through genetic studies in the last year or two that there are vascular protective factors which exist, which explain why some people with familial hypercholesterolemia, for example, don't get atherosclerosis. So hopefully in the next 3 to 5 years, we're going to be understanding some of this vascular protection and the factors that promote it.
And so this is a culmination of 50 years of basic science, I think, and it's really quite elegant. So you have to have the ApoB lipoprotein retention. All these other factors are simply exacerbating, and obviously we want to get rid of them, but if we got rid of LDL in the first place, you wouldn't get atherosclerosis. So, this whole concept, I think, is so exciting because now we have drugs where we can get LDL levels so low, and the idea is to use short-term therapy, intensive therapy, and that lets you avoid lifetime therapy. I mean, how many patients have you said, oh, do I have to take this the rest of my life, when you try to give them a statin? And so I think there's that issue, but there's also, perhaps some long-term safety issues, and everything's just avoided with all of this. So let me just show you some of the basic science, and I think it's quite exciting. This is just one example. There are many others. If you take animal models and you get, special animals that, animals don't get atherosclerosis except like rabbits, hamsters.
All right, if you give them
primates.
if you give them a Western diet, they can get
Right, so you have to
atherosclerosis.
give them, but you have to do some knocking out and knocking in and stuff like that. But anyway, these are cholesterol responding mice, and so they start to get atherosclerosis, and then you take away the fatty chow, and their LDL goes way down. Their total cholesterol in this experiment went down to 11 to 55 over the course of time. And look what happened to the early lesions, completely regressed. The early, more advanced lesions, you still got tremendous regression, but they never totally resolved.
Yeah, you're just left with a little bit of scar, but
That's
they
right.
definitely improve.
That's right, that's right. And the other thing that's really interesting, those early lesions, they're all through the arteries, right? I mean, we think of, your cardiology hat, you've got the stenosis, right? You've got the single lesion.
Well, I'm going to show the pictures in a few minutes.
Yeah, the whole lesion is throughout. And it
Yeah, we'll have
turns out that early stiffening, when you get the regression of the early lesions, the vascular function returns to normal. So you're really healing the artery with this. We also, we have seen regression in more, we don't cath young people. That's our study,
Sure.
right? But
Right.
we have shown that if you get, the more you lower LDL, the more plaque regression you get. So it's certainly something that happens in human, and it also, you get an improvement in plaque composition. We also have data that shows that, again, the more you lower LDL, the more you reduce cardiovascular events. So it's you have to have that whole picture of getting regression of the atherosclerosis translating to events to convince people. But I think just this whole idea of normalizing the vessel is really important, because there's also the potential for this therapy to actually reduce blood pressure, to prevent the development of hypertension. It turns out that the vessels stiffen decades before the blood pressure starts to rise. So if we can maintain healthy, responsive vascular arteries and delay hypertension, maybe even several decades, just think what the impact would be by eliminating the burden of hypertension is huge.
Well, I think the stiffening is key, because we haven't shown any of this data, but one of my colleagues does work with pulse wave velocity, particularly in diabetes and obesity, and it's very clear that vascular stiffening is the first adverse change that you see in younger people. If you have FH or other severe conditions, you can see very small atheroma in adolescence, but it's really the stiffening which is the first adverse event.
And there's also some data in older adults, in their 30s and 40s, if you give them statins, it does lower blood pressure 3 or 4 millimeters. So again, there's all this compelling data, I think, that this is a story that holds together. The other thing that interested us, there's also this idea of legacy effects. So when you do this is a couple trials, primary prevention trials. So you give statins for 5 years, or this other study was 3 years. You stop them, the curves remain separated. So what you've really done is sort of arrested the disease, and they stay at lower risk throughout their lifespan. So again, harnessing this legacy effect, if we stop treating people, would be helpful too.
Yeah, so it adds the idea to the concept that any statin lowering is beneficial, and it's long lasting. So I want to talk for a few minutes about the P-Day study. So the full name is Pathologic Determinants of Atherosclerosis in Youth, and this study, as I mentioned yesterday, started with 15 to 34-year-olds who died accidentally and then had their right coronaries, left coronaries, and descending aorta autopsied to look for atherosclerosis. So this is what a 19-year-old typical white male in P-Day looks like, and you can see a few fatty streaks, but also the beginning of some raised lesions. And this is what the next decade brings: more extensive atherosclerosis, more extensive raised lesions. This is an MRI of a patient of mine who had combined hyperlipidemia, total cholesterol of about 700, and you can see asymmetric thickening of his descending aorta on an MRI. So the atherosclerosis is there very early, and it's actually measurable. Now, if you look at P-Day results, here are just some simple comparisons. This is for 4 key risk factors: non-HDL cholesterol, HDL, hypertension, and obesity. The top panels are the leftward panels in every group of 4 are the younger people, and the rightward panels are the older people. And you can see that as the risk factors progress and as age progresses, there's fairly dramatic development of atherosclerosis. Now, what's important about this is that if you look back in the second decade of life, between 15 to 19 and 20 to 24, if you look at the early lesions, they track with the risk factors, and there's a big difference. However, if you look at raised plaque, the only risk factor below the age of 20 that's linked to elevated atherosclerosis is actually diabetes. But as you move forward in every 5-year increment, the risk factors dramatically increase the expression of atherosclerosis. And the more risk factors you have, the greater the separation. So with this type of data, you can develop a risk score, which I apologize for the size of this, but you can use this risk score to look up the probability of developing atherosclerosis. And so you basically put in the score, and that tells you a probability of future atherosclerosis, which then allows you to begin to identify those people who are at greatest risk for early atherosclerosis. And so if you take these same maps that we've been showing you and link them to the score, you can see the prevalence of raised lesions with each 5-point increase in the score. And each point is linked to a year of vascular aging or atherosclerosis development. Now, this is from the original publication, and it shows the prediction of the risk scores and the increase in or the likelihood of having advanced lesions as your score goes up. And it turns out that if you get to a relatively high score, which is the equivalent of about 3 or 4 risk factors, then you have a 40 to 60% probability of having advanced atherosclerosis. Now, another key finding related to PDAY was looking at risk early in life and then measuring atherosclerosis later. So our first publication looked at the PDAY score in relation to coronary calcium 15 years later, and we looked at tertiles in 2 ways. First, were you in the lowest score at baseline, and then we looked at change in score over time. And essentially, if you're low, is this going to move it? You're down here, this is your index, and if you're high and you're in the highest tertile of change, 9 times more likely to develop CAC. So both baseline CAC, or baseline risk, and change in risk create an increment or a stair-step increment to increasing likelihood of CAC. But these original points turned out to be the strongest predictor. We then went on in year 25 in Cardia and repeated the same study. And what they show is that if you go by measure risk or PDAY score by every exam year, you can see that the likelihood of developing CAC is highest in year 0 and year 5, and then lowers substantially year by year. So actually, the best prediction of coronary calcium is made 15 to 25 years before you measure the CAC. And one of the reasons we think that CAC has value is that it's actually a measure of chronic risk exposure. So then Jennifer went and took these data of the risk and the probability and looked and developed a table of people with 40 to 60% probability of developing an atheroma and greater than 60%, and stratified this by gender. So that this then becomes a group of people who you might think about curing atherosclerosis at a much earlier age. The next thing we looked at was FH as a model, and I showed you this slide yesterday, which shows that we can tell that atherosclerosis begins about age 10 in FH. And this is CAC in a 14-year-old patient of mine with a total cholesterol of over 400 and a father with an MI at age 28. So here is atherosclerosis in someone with FH at age 14. And the data from Bert Wiegmann, the follow-up of his initial statin trial that was published in in just this year in New England Journal shows that if you're a child with FH, by age 40, essentially 0 events, while the parents have an event rate of up to 25%, and also there's a mortality benefit in the comparison, and he also showed in the study lack of progression of carotid IMT. So I've shown you this before. These are the prevalence maps for age and non-HDL cholesterol. So we believe that the P-Day data, FH is a disease model, and all the trial and other basic science data that Jennifer presented provide the background for thinking about early intervention to cure atherosclerosis. So what trials are we going to do to prove our hypothesis?
Well, I think you've thought of a trial already, haven't you?
Right. So there actually is a trial. I'm not in it anymore, but it's called the Do It trial, and it's funded by NIH. And they're taking actually obese adolescents with high cholesterol and putting them on a statin, and they're going to use pulse wave velocity as the endpoint to see if they can have an impact on vascular stiffening over 2 to 3 years. So that's the Do It trial. That probably results for that won't be ready for 2 or 3 years. And then the next is the next trial that we've thought of is, and I think this links to a lot of the work that Raul has done, and Ian probably helped inspire this slide, is to really know, because the risk score only, and there's tremendous variation in who gets atherosclerosis, and only about 40 to 60% of the people are actually going to be positive. We think that subclinical measures are going to be really key in risk stratification. So how can you develop evidence that shows that these subclinical measures are going to be important? So this is for FH. You could take a group of FH patients and perform your subclinical atherosclerosis measure, whether it's CAC or IMT or something more invasive, and divide those people into 2 groups, those who test positive and those who test negative. And then you do your classic randomization with higher and lower intensity treatment. And that gives you 4 groups who are in your trial. And all of these comparisons have meaning in terms of the value of the intervention and the value of the being test positive or test negative. If it's true that being test negative means you have these vascular protective effects, then you should see less benefit of your treatment in this group than you would see in this group, for example. So a trial design like this then would provide the rationale for using atherosclerosis measures in risk stratification.
And I think that would be really helpful with FH, because it just would be, unfortunately in the US, we have people who write guidelines who don't believe in statins in children and all this other stuff even, but PCSK9 inhibitors. But wouldn't you love to get everybody with FH have LDLs of less than 100 from childhood, right?
Sure. And I think that's the virtue of the follow-up study from the Dutch, is the mortality benefit is actually infinite because the denominator is 0.
Exactly, right. So this is kind of, I think, where our Cure Athero trial, what we're thinking about, and we've alluded to already, is can we recapitulate the risk of those PCSK9 loss of function heterozygotes with intermittent statin therapy, you know, sort of like we treat cancer. We should maybe treat atherosclerosis like we treat cancer, right? An induction therapy where you regress the atherosclerosis, maybe a maintenance phase, and then a retreatment if things progress. And so again, lifestyle isn't enough, and we really think that you're going to have to use drugs. So we've actually submitted this trial with NIH's strong support, which didn't get funded ultimately, so we're kind of rethinking this thing. Depressed.
We're on antidepressants,
Well, then I'd convinced the medicines company to do it, and they got bought up by Novartis. But anyways, hopefully someday this is going to happen. So the whole idea, we think we should start with a proof of concept idea to really recapitulate that animal data, which shows that, you know, intensive LDL lowering early has profound effects on regression and vascular function. So we'd like to pick that susceptible group, you know, 25 to 55, a little older for women, overweight, obese with risk factors, and then also with some uncalcified plaque present, again, to show those who are most susceptible, probably genetically, but that is something we look at. And we found, again, that if they had a PDAY score of 25 or older, there was a 40% probability of having uncalcified plaque. I did an MRI, looked at some MRI as a sub-study, and CTs, and that's really the case. The PDAY score works quite well. And our idea would be to just randomize 130 subjects, and then basically, actually, if we get more money, that was cheap. You know, if I
Right.
get another $10 million, we can do 800 subjects. But we'd really like to find those who are the most responsive to therapy in terms of big regression responses, and then move those people forward into clinical trials. The idea would be to treat people for 3 years, randomize them to usual care as the control group. These really aren't people who are candidates for therapy according to the guidelines. I mean, if they had an LDL over 5,
Right.
of course they'd be treated and wouldn't be eligible. And we'd use a statin, probably a high-intensity statin, a PCSK9 inhibitor. Sanofi had donated drug for it, with or without ezetimibe, to try to get the LDL down to 20 or 40 for 3 years. And the primary outcome was CT angiography, low attenuation plaque volume, to see if we could regress that small amount of plaque we saw, but also to couple it with some more imaging, PET, some inflammation imaging
Right.
and things to really see what's happening to that early atherosclerosis. I think the whole idea, I think we need to do some studies
Right.
to identify the sweet spot for the most susceptible responsive population, but we could easily move this into a clinical trial with 10,000 people, 5 years, to show a cardiovascular outcome benefit, which is what we're going to have to do to convince people to do this. So the genetic, I think the thing we're working on right now is doing a genetic risk score to help us pre-screen people. Not just risk factors, taking the top quartile of risk factors and then the top quartile of genetic risk, and then putting those people in our study, because we think those are the ones who are going to have accelerated atherosclerosis. So I think that's probably where we're headed. And it turns out the latest data from other studies of people with premature MIs is it a 6 million SNP chip.
Yeah.
Doing the whole genome sequencing is just as good as doing a 64 SNP chip. So that was good news, that we can do the little cheap little 50-cent chip.
But I think
that should work.
I think the genetic risk scores are important in that they essentially give you another major risk factor. So if you look at the people who are on the high end of the genetic score, it's about 3% of the population, and that triples your risk. So that's exactly the same as smoking, super high cholesterol, super high blood pressure. So it essentially gives you a 6 risk score and allows you to further refine your risk estimates, and probably those people don't have the vascular protective genes.
Right, and I think we have seen already some suggestion of that from the treatment trials where they've done genetic risk scores, and those at the highest genetic risk actually are the most responsive to statin therapy, because we really seem to be getting the susceptible people.
Well, they also don't have LDL receptor defects. So I think what's interesting about the polygenic inheritance or these other risk scores is it turns out that statin response is much greater in that group.
Yeah. So we think we have a good story here. I think it needs to be the first trial, but we could quickly move into a cardiovascular outcomes trial. It turns out the EMA will approve drugs for imaging indications. You have to have a cardiovascular outcomes trial, but you can also get approval for imaging studies, which I think would be pretty important if we could do the FH study and
Right.
this study. So we're also arguing that we need these studies to really lay the groundwork for the genetic revolution. I promised you I would talk about that. This is where we're headed, people. You think PCSK9 inhibitors were expensive, but exciting.
Life is expensive.
But this is the infamous now Dr. Who did embryo actually, germline manipulations and got into a lot of trouble with that. But there's another guy, there's a Russian guy who's going to do it kind of with everybody's blessing. So that's where we're headed. And our dear colleague, Sek Kathreson, has just formed a company called Verve Therapeutics. So I think they're privately held, though, so you can't buy stock. But they're actually going down this pathway of, they've identified, he's a famous Harvard geneticist, 7 human loss of function genes, like the PCSK9 loss of function genes. And they're actually coming up with some CRISPR things that they can, manipulate in adults, snip out maybe the PCSK9 genes and induce PCSK9 loss of function mutations. And they're actually moving forward with this as a therapeutic agent. And the US FDA has a framework now for moving forward with this. So this is just around the corner. There are lots of issues with this. I think it's exciting. I don't know, have you all heard of CRISPR? And you cut out the bad genes and put in the new genes that you want. There are some technical issues which seem to be overcome. So this CRISPR prime seems, you don't want to insert your gene in the tumor promoter region, right? Or the tumor suppressor region. So they're working on those sorts of things. I think the first trials will be in adults, and then we won't have to give statins for life and PCSK9 inhibitors. But people are actually talking about gene editing babies. But I think we need to do studies like ours to really show that it's even possible in humans, because all we really have are animal data.
Well, I think we have the ability to prevent atherosclerosis. I mean, when I started 30-some years ago, my idea was just to get the patients to a point where they got to age 60, and then it was internal medicine's problem. But as I got involved with patients, as I said, no patient that I follow with FH wants to ever have a heart attack. So the real baseline is zero disease. And how do you get there? And I think also what the contemporary epidemiologic data show is that there's probably a threshold to the current approach that we take to preventing not just atherosclerotic heart disease, but heart failure. So that unless we recognize that these conditions start very early in life, we're not going to be able to have a big impact on disease prevention until we actually start doing the preventive efforts at the very early end. And I really want to point out that our goal is not to give meds to everybody. Our goal is actually to prevent early target organ injury and to allow normal organ function over time, and to think about intermittent rather than, to have a goal of intermittent rather than lifelong treatment. So that's it.
Yeah, so we totally agree. So it wasn't
That's
a
right.
Any questions, comments?
We finished in 40 minutes.
I know.
Philip.
Where are you looking for money for this? Because this is really important.
Well, we tried NIH, actually with NIH's blessing, and could not sort of get it funded. We're still going at it with NIH, but I think we're probably going to have better luck. So if you talk to anybody for Novartis, tell them that they should fund this study.
What about some of the philanthropic organizations?
Do you have some names? We'd be happy to. Actually, every week
some of the names are so well known that you know them.
Yeah.
They're worth approaching.
Yeah, we probably.
Well, maybe we can convince Tom Steyer not to run for president.
That's right.
He could fund the trial instead.
I mean, every week I get emails from people, the tech people who get, so I suppose we could we should put together we don't think like entrepreneurs,
That's right.
We're scientists. So.
I have a comment and a question. So in my country, treating patients with statins, if they have not had a heart attack, is very difficult. And the main reason is that doctors don't believe they should do it. Despite the French Atherosclerosis Society telling they should, despite the French Cardiology Society telling they should, primary care doctors said no statins unless you had a heart attack. or you are FH. And then what comes in fashion is like, if you're older than 75 or 80, you shouldn't bother taking a statin. So I know we're 10 billion on this planet and we're not an endangered species. And probably
It's in our club.
room for younger generations telling that. But I have to give a talk in 3 months' time advocating for primary prevention. And I got all your pros for curing atherosclerosis and starting to lower LDL with statin and other drugs early. But what would be a sensible argument so people listen and actually make it?
Well, I think that's why we titled our talk, Building the Evidence.
Right,
I think we really have to have cardiovascular outcomes trials that
Right.
show that this works.
Yeah.
Because otherwise,
Yeah.
we're not going to convince
Yeah.
the primary care doctor.
Right. So I think the most potent arguments, so I think FH is a great model, and I think the data that was just published with not just an event benefit, which is huge, but a mortality benefit as well, is very compelling as one story. The second is the P-Day data, where it's very clear that if you have multiple risk factors, you have the same type of risk as FH. And then third is any young person with diabetes. And then there's the epi data related to cardiovascular, no impact on cardiovascular mortality at relatively young ages. And then once you get to there, then there's the meta-analyses that Jennifer has done looking at relative risk and benefit. The argument against this is event rates are relatively low, but I think that ultimately what you want to do is get to no event rates. I think one of the real problems with trials, and I think that's been highlighted in some of the discussions, is that, and IMPROVE-IT is kind of the greatest target for this, but you have these very small increments of benefit, and then you get an NNT of 20 or 25 people. You say, okay, well, I can treat that many people and prevent a heart attack. But what is the real comparison group? It's really not the lower intensity intervention group. It's these people who have no risk factors, who live to be 85 or 90 without any heart disease, right? So you have an event rate and IMPROVE-IT. In IMPROVE-IT, what you showed is that the time to an event rate in 7 years is 33% versus 31%. Well, we know that if you have no risk factors at the age of improvement, your event rate is 7%. So there's still this 25% gap, which is huge and dwarfs the benefit that you see in IMPROVE-IT, and frankly, in a lot of the statin trials, so that are initiated much later in life.
Well, that would be the idea of the outcomes trial, is we pick this susceptible population, and if you have an 80% risk reduction, you don't need a very big or long study. So
the idea of an outcome trial is essential. What do you need before that?
we need to do our imaging trial to show that this is proof of concept, that we can halt and actually reverse atherosclerosis and normalize the artery.
Because what you're suggesting, I find eminently plausible, almost certainly true, but it's a paradigm shift from the way most people are thinking. So what do you
Welcome to my world.
what do you need in the way of evidence?
Yeah.
I need $7.5 million, and I can do
Here, let me
my
answer this
trial.
So I think that the evidence is key, right? And I think that beyond, so I think there's two key concepts. Concept one is that the disease is atherosclerosis, not a myocardial infarction. And concept two is that the risk factors for myocardial infarction are parallel, but not exactly the same as the risk factors for atherosclerosis development. So I think, for example, we talked about passive smoke exposure. Lp(a) probably fits into that as triggers, as two kind of low-hanging examples. So I think those two concepts, and then the idea that if you never have atherosclerosis, you can't have a heart attack, right?
Yeah, all of what you say is sensible, and there is circumstantial evidence in favour of, for example, the legacy effect, the fact that there are some people who have no risk factors and live to be 100 and die of a motor vehicle accident. But what you're suggesting, I'm old enough that I can remember clearly when the vast majority of my colleagues said, "You wasn't on cholesterol, what a waste of time." What an absolute waste of time, and they believed it. And it wasn't until the evidence evolved.
Exactly, no,
Sure.
exactly right.
And
But I think we also need to do some paradigm shift conceptual things, and I think this slide says it. We need a better paradigm to treat the actual disease, which is atherosclerosis. We need to be more like, would you wait to treat hypertension till you had end-stage renal disease? No, that's where we're at right now with
so the real
cholesterol.
message is,
Yeah.
refine your hypothesis into something that, however skeptical people may be, which is testable, and I think you're very close to that, and then test it.
Yeah.
And at that point, you'll know how to design your outcome trial to put the final through.
Well, we also need people to stop using the term secondary prevention for, all the people who get into the current trials. I mean, I think, I agree with your comment in one of our side discussions yesterday about TNT, but I think, it would be nice if we could do a design like that where instead of going from like 10 of atorva to 80, 10 plus ezetimibe, for, and there's lots of different kind of variations on a theme, but I think if we believe that we can regress in the same way in an animal model that you can regress atherosclerosis,
Well,
the data are there that we could do it.
There are two aspects. One is the regression.
Yeah.
The second, and much more important, is the prevention. And that is to say the artery has a memory. If you can actually prevent the disease occurring in that artery early on. Okay, some people will need some treatment, but it will be intermittent, will save vast amounts of money and allow people to live longer and healthier. So you've got a huge battle, but this is one you've got to win.
No, we're young, right, Sam? Right?
You're young. I like being
Other
old.
questions?
I like being old. Well, this was successful.
All righty, well, we've convinced you all, so there's no harm. That's why we're so enthusiastic about statins, just go out and go forward, yes. Yes,
So, antioxidant and inflammation are very much in fashion, okay? You just said CRP is unuseful, am I right?
Well,
Well,
I think the framework that we're trying to get out there is that those things are important when you have advanced disease, because the vessel is at the point now where risk factors have overcome the vessel's ability to heal, and there's ongoing inflammation. So I think all these studies are basically at the end stage of the model rather than prevention. So I think that's why I suggested that we need to get rid of this idea of secondary prevention. You're really treating people who have prevalent heart disease.
Some of them just
Yeah.
happen to have had an event along the way.
Right, yeah. So they have prevalent heart disease. So I'm not saying those things aren't factors, but measuring those early in the course of the disease, of the process, isn't going to be helpful. What you want is for them never to be a factor.
Okay, and
The other thing is that, and maybe Phil can comment on this, is I think when you have something like psoriasis or these other inflammatory conditions, they may be pro-atherogenic in the sense that they alter the body's ability to heal. I think the other great misconception in atherosclerosis development is people forget about the healing part of that your vessel is healing as well as being injured. And I think you have to have that dynamic in mind.
The other thing you mentioned is that some FH patients, for reasons we don't know, will not develop premature, they will have athero, they will not develop premature cardiovascular disease. So what are your suggestions to understand what is happening in those patients? And you can do whole genome arrays and look at all the genes. A lot of people have tried, but do you have a hypothesis?
well, so the most common presentation for women with FH in the cath lab at age 80 is they have an HDL of 80 also. So there are again, these protective factors or
Yeah.
resilience in the face of this high
Mhm.
burden. But once an FH patient has a risk factor,
Yeah.
they're on the pathway.
Y-
So
yeah.
I think that's what all the studies, and
Yeah.
Raul, maybe you can comment. You're doing
Yeah.
a lot of work in this
I mean-
area with risk stratification and
Yeah,
FH.
just like to add, heterogeneity of the disease, that's the issue.
Mhm.
40% of FH patients, actually by the age of 40, don't have plaques. They have calcium scores of 0, okay? Of course, these patients are being treated with statins for many, many years. And this, I think, might have made a difference for a lot of people. But we have people that actually are resilient, right? So, because we have old people with FH that never get an MI, right? Sometimes we find people like that. And there's all this discussion about calcium score of 0 as maybe a trigger for not treating. I don't agree fully with that, but I understand that actually there are things that protect us against atherosclerosis. But what I want to say is actually, to develop a trial like this is a real challenge, right? And until then, I think we have tools that can help us identify higher risk individuals that never had a heart attack, okay, never had angina and so on. And I like the imaging for that. So I think imaging can help us identify early atherosclerosis, right? So the carotids for younger people, CAC scores of CTA for people who are after the age of 30, 35. And if we find plaques, we need to be aggressive. I think the corollary of the power of 0 is the contrary, right? So if you have plaques, you have to be very aggressive because those individuals have a greater risk. And we should not miss this opportunity. And sometimes when we see guidelines, they say, oh, we don't have a clinical trial saying that you should use imaging for starting treatment, right? But on the other hand, we don't have any clinical trial saying that if I use the Framingham risk score or the pool risk equation, I should give a statin for the patient because they were not randomized according to their risk. So I think it's the same thing. So we have to use tools that we already have to identify higher risk patients and be very aggressive when we find the disease.
Yeah, but I wouldn't, I mean, on the ground, I agree with you, but I think that we still need to think about trials like the design that I outlined, because I think we're too focused on the disease. We also need to identify those factors that are associated with absence of vascular injury. I think, you know, there's an Achilles heel to epidemiology that nobody ever talks about. And that is, for example, like the PDAY score, there's still 40% of people who don't have atherosclerosis despite all those risk factors. Who are they? How did they get there? I think we need to understand that. And I think if imaging truly works, it's going to identify those people who have vascular protective factors, and they can be studied. And who knows, you may end up with a pharmacologic target from studying those people as well, right? A healing target. So I think that, and this I think we both strongly believe in, is we can't jump to just kind of drinking the Kool-Aid and saying this is the answer without certain key trials designed to address the type of hypotheses, you know, that Philip has challenged us to develop. I think you have to start with those trials to confirm the hypothesis and to advance the knowledge, and also to identify people both who can tell us how to heal the vessels as well as people who have aggressive risk progression, you know, for genetic reasons.
So are we, I mean, for curing atherosclerosis, are we promoting here for vaccine against, you know, anti-cholesterol and against also diabetes?
Yeah, I mean, I think that's always the hope. People are trying to develop vaccines, and it's not really working. So, you know, PCSK9 vaccines and things like that. So obviously something like CRISPR to knock out PCS, you know, I mean, there's all these things off in the distance. But we think we have the tools at hand right now. We can explore this hypothesis and be ready when we can give large masses of people a primary prevention. And I think we're going to have to do a better job with marketing to convince people to, you know, we have anti-vaxxers and all sorts of others hysteria out there.
Yeah, I mean, those high-end technologies ultimately aren't going to solve, 1 billion people with prevalent heart disease, right? So I think we need the proof of concept, and then, the paradigm shift is the way people think about these problems. And so that's all. But the CRISPR and those types of studies will help us with proof of concept. And then I think, and I know people are working on this, is how do we advance our evidence evaluation paradigms beyond just clinical trials? Because there are major gaps in knowledge that are created by the design of trials. And they're not perfect either.
All right, so I'm exhausted. Can we stop?
I need to go to the pool.
Okay.
I need to
Any last
exercise
questions
to
or-
prevent my heart disease.
All right, well, thank you so much. It was fun to share this.